Welcome to ZoomInData. In this session, we're exploring the powerful integration between Azure Data Factory and Azure Synapse Analytics, a combination that lets you build end-to-end analytics pipelines, from data ingestion and orchestration to advanced processing and visualization, all within Microsoft's unified analytics platform. We'll cover how they work together, key integration points, security, cost implications, and real-world patterns. Let's dive in and see how this duo supercharges your data workflows. Azure Synapse Analytics is Microsoft's unified analytics platform that combines traditional data warehousing with big data capabilities. It offers SQL pools, both dedicated and on-demand, for structured data processing and analytics. Spark pools enable big data workloads using Python, Scala, or R. You can choose serverless for pay-as-you-go or dedicated compute for predictable loads. It integrates seamlessly with Power BI, Azure Storage, and of course Azure Data Factory, all managed through the intuitive Synapse Studio interface. Integrating ADF with Synapse makes sense for building complete end-to-end pipelines, from data ingestion and orchestration in ADF to processing and analysis directly in Synapse. You can reuse existing ADF pipelines right inside Synapse Studio, benefiting from unified security and governance across both services. It also improves cost efficiency through shared compute resources and simplifies management with a single pane of glass. Ultimately, this integration unlocks advanced analytics within a cohesive platform. Synapse Pipeline is essentially the Azure Data Factory runtime embedded within a Synapse workspace. This means you can create and run full ADF-style pipelines directly in Synapse Studio without needing a separate Data Factory instance. You'll have access to the same familiar activities like copy, data flow, and more. Synapse manages the back-end, supports Git-based version control, and lets you debug and monitor everything right from Studio, streamlining your workflow. Creating a Synapse pipeline is simple. In Synapse Studio, navigate to Pipelines and click New Pipeline. From there, add activities such as copy for data movement, lookup for metadata, for each for iterations, and so on. Parameterize them to make pipelines reusable across datasets. Set up triggers like schedule, tumbling window, or event-based for automation. Once ready, publish and deploy to your workspace, then manage runs and status through the integrated Monitor Hub. Shared Integration Runtime allows you to link an existing ADF IR directly to your Synapse workspace. Azure IR options autoscale and are fully managed, while self-hosted IR supports on-premises or hybrid scenarios. This reuse means you don't provision separate runtimes, just configure it once in Synapse under Manage and Linked Services. For security, enable VNet integration and private endpoints to keep data movement private. For data movement, use ADF's copy activity to ingest data directly into Synapse SQL pools. Stage data in Azure Data Lake Storage Gen 2 for faster loads. Leverage Polybase or TSQL for efficient bulk operations. Implement incremental patterns like watermarks or change data capture to avoid full reloads. Enable parallel copy for handling large volumes quickly, and track performance metrics right in the Monitor Hub. Synapse supports mapping data flows powered by ADF's Spark engine, allowing complex transformations like joins, aggregates, filters, and more. Execution runs on Synapse Spark pools. Choose serverless for flexibility or dedicated for consistency. Use debug mode to test flows without full runs. Output results to Synapse tables, lakes, or external storage. For efficiency, apply partitioning and caching to speed up processing. Security is seamless. Use managed identity for credential-less authentication to Synapse resources like SQL pools or storage. Store secrets securely in Azure Key Vault, referenced in pipelines. Apply RBAC roles such as Synapse Contributor for management or Reader for view-only access. Enable private endpoints for network isolation, and ensure encryption with transparent data encryption and TLS for data in transit. All activity is auditable through Azure Monitor logs. Monitoring in Synapse includes the Monitor Hub for tracking pipeline and activity runs, plus triggers. Synapse adds specific metrics like Spark job durations and SQL query performance. Configure diagnostic settings to send logs to Log Analytics for querying. Set up alerts for failures or excessively long runs. Integrate fully with Azure Monitor, and build custom workbooks for tailored dashboards showing pipeline health and resource usage. Cost-wise, Synapse charges for SQL and Spark pool usage based on DWUs or vCore hours. ADF orchestration fees apply to activity runs executed in Synapse pipelines. Reusing a shared IR doesn't add costs. Data movement via copy activities incurs DIU hour charges. To optimize, auto-pause idle pools and use incremental loads. Track everything in Azure Cost Management to set budgets and avoid surprises. Best practices include starting new analytics projects with Synapse pipelines to leverage the integrated environment. Reuse your existing ADF integration runtimes to avoid duplication. Prefer managed identity for authentication instead of storing keys. Always stage data in Azure Data Lake for better performance. Enable Git integration for proper C/CD. Monitor both costs and performance on a regular basis, and layer security controls like RBAC and private endpoints for comprehensive protection. Common patterns include ingesting data from external sources via ADF and loading it directly into a Synapse SQL pool for analysis. For ETL, use ADF pipelines to orchestrate Spark transformations within Synapse. Hybrid setups leverage self-hosted IR for on-premises data movement. Real-time scenarios can use event triggers to feed Synapse streaming pipelines. And for machine learning, pipeline outputs can flow into Azure ML models for training and inference. In real-world scenarios, teams use this integration for daily ETL jobs pulling from on-premises databases into Synapse warehouses. Incremental loads from Azure Data Lake to Spark pools handle large-scale transformations efficiently. Real-time fraud detection leverages event-triggered pipelines. Many migrate legacy SSIS packages to modern Synapse pipelines for better scalability. And for secure hybrid analytics, private endpoints ensure safe connectivity without public exposure. Here are some conceptual interview questions. What exactly is a Synapse pipeline, and how does it relate to Azure Data Factory? Explain how shared integration runtime works in a Synapse workspace. How would you secure an ADF Synapse integration? What are the cost differences between standalone ADF and running pipelines in Synapse? What are the key benefits of using data flows within Synapse? Which monitoring tools are available for Synapse pipelines? And when should you choose a SQL pool over a Spark pool? Now for scenario-based questions. How would you migrate legacy SSIS packages to Synapse pipelines, including key steps. Design a real-time data ingest from Kafka directly into Synapse. A copy activity to a Synapse SQL pool is failing. What troubleshooting steps would you take? How to optimize costs for daily Spark jobs in Synapse. Secure an on-premises data load into Synapse using best practices. That brings us to the end of our session on integrating Azure Data Factory with Azure Synapse Analytics. Thank you very much for watching. If this helped you understand how to build unified analytics pipelines, please subscribe to ZoomInData for more content on Azure Data Factory, Synapse, and data engineering. Like the video if it was useful, leave any questions or your experiences in the comments, and share it with your colleagues or network. Thanks again. See you in the next video.